steadily it flows, the endless stream of time from then to now, what we call history. Then, food and water was what primeval man was after as he pushed his way through forests, hunting, searching. And as he grew wiser, he dug into the earth with a wooden hoe. Then, now, today, with a shaft of steel, we too dig into the earth. Primitive man's transportation, step by step. Then, now we can move anywhere. Through history, flashes of inspiration have penetrated the darkness of ignorance, shown the way to what is now known as the source of all energy. It is called the radiant energy spectrum. The story of man's scientific progress is revealed by this spectrum, which holds for mankind an overflowing harvest of radiant treasures. Early in the flow of recorded time, wise men came to believe that water was one of the 5 basic elements making up the world. Fire was another. Earth, surely earth was one of the ultimates that could not be subdivided. So were mist and air, making all 5 elements that compose their universe, they thought. But in the thrust through the centuries, more was to become known. By the light of a flickering torch, more than 2,500 years ago in Greece, an experiment. A block of amber rubbed against a sheepskin attracted wood shavings to it. Why? Why? There was no answer at the time. But the word for amber in Greek is electron. 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 In the late 19th century, a vacuum tube gave modern meaning to that word. The tube glowed when electricity flowed through it, a current consisting of charged particles, electrons. In another laboratory, a man named Edison looked down on the sudden glow within a carbon filament light bulb he had invented. That first surge of light, known as Edison's effect, revealed much about the movements of electrons as a source of energy. Out of the theorizing, experimenting, inventing of men like James Maxwell and Heinrich Hertz came the proof that there were visible and invisible waves of energy traveling through space in many different forms, creating what we know today as electromagnetic waves, which move with the speed of light. Light, as seen by the human eye, is composed of various colors. When it is passed through a glass prism, one kind of spectrum is formed. The familiar color spectrum. But this rainbow is only a fraction of our entire radiant energy spectrum. For beyond the light which the eye can see, an infinite number of radiations exist, all of them invisible, fanning out in undulating electric and magnetic fields, traveling in countless different frequencies and wavelengths. Some of these waves can be felt as we move in on our symbolic interpretation of the radiant energy spectrum. Here the waves are known as ultraviolet, causing sunburn. In yet another part of the spectrum, we feel the heat of infrared. There is a vast additional span of electromagnetic radiation, from long-wave radio signals to cosmic rays, which are shortwave, all forming the radiant energy spectrum. Our spectrum may be unseen, but it is here, everywhere. The treasures from our radiant energy spectrum have created a tremendous rise in our standard of living. To put these treasures to work, great organizations have moved to the forefront of world industry, reflecting an unprecedented pattern of growth. Their task? To generate, control, detect, and harness the waves of radiant energy. The results of all these efforts can be seen by moving into the spectrum. Starting out with the area of voice frequencies, the telephone.
Oh, and I'd like to order 2 dozen of the large size.
When I get to L.A., I'll call you from the airport.
Doctor,
Well, thanks a lot.
Jimmy's running a fever of
Bye.
102. And
I'll need delivery by the 4th.
That man knows how to get things done. He certainly can do. Do you remember the name of that
I was in the
Tokyo office on Monday?
What a state. And it's just
I'll have
past
to
the
put it in
green
an
light.
alternator, and your battery's gone dead.
Up to the hill for 2 blocks.
Your call to London.
For 42. Don't make it 42 and a quarter. They'll need 2 more tractors to get the job done.
The wires sing out with a symphony of information, gossip, decisions, romance, questions, answers, emergencies. Today, every new telephone customer joins a growing family with many millions of relatives. To supply the telephone man with the right equipment, a huge capital investment is required, whether for a technician in a switching center or a pilot of a helicopter laying cable over remote country. Result, an everyday miracle. Behind that miracle is the manufacturing enterprise that was formed way back in 1891 to develop the world's first automatic telephone system, and over the years has continued to be a leading producer of modern communications equipment. Miniaturized components play a big part in the phone connections of today. An unbelievable dexterity of fingertip control to make possible the computerized telephone system, electronic automatic exchange, called EAX. The basic unit is only a fraction of the size of conventional systems. It will ultimately make possible even faster and more versatile service. EAX will also spur the growth of something else. Business data transmission over telephone facilities, machines talking to machines in a new language of tones and pulses. Each tone, each pulse, each action must be absolutely right. That's where a rigorous program of quality assurance comes in. Take a key unit of gear and drop it, and hammer at it as a test. If it's supposed to stretch, stretch it about 500,000 times as a test. If it's supposed to switch, switch it 40 years worth as a test. If it's supposed to dial, dial a few million calls as a test. And as a test, put it under conditions of about 50 degrees below zero. That's how dependability is born. Above all else, though, quality comes out of the productive skills of people. Equipment may supply the muscle of an operation, But human beings are still the heartbeat. People everywhere benefit from man's growing mastery of the radiant energy spectrum. A vast number of jobs have been created as out of the spectrum entire new industries are born. Television. One of those industries still young, with much to look forward to. A communications medium that is far more than just entertainment. The mind and imagination is led away from everyday care with a simple click of a switch. Families knitted together, seeing, wondering, at home as at school. Fascination with this window on the world. Television is so much a part of our life today that the modern consumer is determined to have the best that creative design and technology can offer. A wide range of cabinet designs, available for every taste. In our radiant energy spectrum, we go now to a point where the wavelengths of electromagnetic radiations become shorter and the frequencies higher. The area of the microwave. The microwave tower performs an important role in our age of space. In experimental situations, highly sensitive antennae are developed and thoroughly checked out before they are made part of the system for communications, satellites, and other space vehicles. Like an endless stream of rifle bullets, the microwaves are beamed to a satellite, then relayed back to a receiving station somewhere on Earth. Experts applied this principle to Early Bird, the world's first commercial communications satellite. An advanced solid-state microwave system was developed. It became instrumental in history's first relay of a broadcast live to the United States from this Earth station in far-off Italy. Further into the radiant energy spectrum, you soon arrive at the uncharted areas, the unknown areas. It is here that the store of human knowledge is growing rapidly, spurred by one overwhelming need: communications for national defense. Instant communications all the way to the rim of the globe. From frozen Arctic to maneuvers in steaming Panama. Today's Army travels on its communications. A call for air support results in action now. A closely guarded installation within the United States. The Defense Department seeks out answers from industry scientists and engineers. Those answers become mighty weapons as the Minuteman and the Moby Dick, a mobile battlefield computer. Civilian experts work with the military, teaching the armed forces to use the newly developed equipment. Step by step, technical training programs are prepared. from original concept to performance. An industry leader developed, engineered, and produced the communications systems for America's atomic submarines. Not all the radiant treasures of the spectrum are in the mysterious world of the unseen. Within that part of the spectrum our eyes can see, there are many opportunities for developing benefits to mankind, as through the use of visible radiant energy, or light. The light of a flashbulb captures the warmth of a family. The light of a flashbulb helps to record those moments to remember. A source of a galaxy of modern lights that is a long, long way from the flaming torches of primitive man. A sea of bulbs, all shapes and sizes, march off the assembly line in endless close-order drill. Today, light comes from more than just bulbs. Panelescent lighting, panels that will give off illumination from their entire surfaces. This soft glow contrasts with the rapid and distant flashes along the runway that guide an airplane to a safe and sure landing. Move further along then on this spectrum of benefits for humanity, from the tiny fragment of the infinite that is visible light, again to the unseen. To the region of the X-ray. The X-ray and countless other techniques made possible by the spectrum are vital tools in today's research laboratory. A crucial component of electronic switching in the telephone industry. Example, a tiny reed magnified hundreds of times. The penetrating eye of the electron microscope would assure that it performs up to standard. This infinitesimal link lost to the naked eye amid a highly complex unit. A small speck of dust can also not be seen, but it is the enemy of the white-clad figures in the immaculate area known as the clean room, where delicate devices are assembled. Contamination on a component could result in failure. Here, purity now means reliability later. Then, moving on past the X-rays, one of our many radiant treasures, we come to a band of the spectrum developed only in the recent past. But with gathering speed, it is looming up to be all-important to humankind, the area of atomic radiation. Specially designed containers carry the atomic fuel which powers the pulsing reactor. a great new tool which demands the most careful procedures for handling by today's men of science. In industrial laboratories all across the land, men of science probe, inquire, experiment, work out problems in the specialized language of research.
So you see, Frank, if we're going to get a phosphor, it's going to have a higher lumen equivalent than this red cadmium zinc sulfide. It's going to have a narrow band emission.
Well, if we want an emission which is narrower than that of the manganese, we may have to go to a rare earth ion.
Well, that means only samarium or europium, and samarium...
Europium, a rare earth material. Was it perhaps the key to a new breakthrough in color television development?
Well, that means that we're going to have to favor the transition from...
Research in one area often results in findings in another. Case in point, from experiments with a laser and its intense beam of light, minds of men saw something that could be applied to a problem facing television tube manufacturers. For years, the weakness of the phosphor making the red color had forced the downgrading of blue and green. Color balance had been achieved all right at the cost of color brilliance. In laser research, elements known as rare earths were being used. Why not take one of them, europium, and create an intense and true red phosphor? Then blue and green could be advanced to the higher red level. First, small quantities were painstakingly formulated. Amid the heat of a furnace, the cool darkness of the laboratory, progress. Slow at first, then the pace quickened. A restrained excitement built. There was no question now. They were ready for the next step. So representatives of the subsidiaries involved were called to a series of meetings. They were ready to put the material into production. Problems were cleared. Commitments made. The timetable set.
We're ready immediately, and it's a matter of how soon you can get them to us.
Well, give us 2 weeks.
Well, fine, let's go then, Paul.
Industrial teamwork in action. And what is talk becomes truckloads. Plans become production. Next stop for the end product of research, the homes of television viewers all over the world. There are no boundaries, no ceiling for the bold and new. Speaking of the growth and development that lie ahead is the chairman of the Board of General Telephone and Electronics, Mr. Donald C. Power.
Putting to work the tremendous potentials represented by the radiant energy spectrum is a never-ending challenge. The challenge of constantly developing new services and new products. To put it another way, the only thing that doesn't change is change itself. Change in terms of progress. Change in terms of serving the public in more and better ways. What I'm really saying is, the spectrum is our business in the general system. And that certainly ought to give us plenty of room to grow. We've already come a long way in communications and electronics. But there will be even greater growth in our future. We're ready for it. We're confident the best is yet to come.
From the everyday familiarity of the telephone through the entire span of our spectrum, the future is bright. Mostly unseen, unfelt, but it is here, everywhere. Our spectrum, holding for mankind now and for the future, an overflowing harvest of radiant treasures.